Hi, my name is Nicholas Boyd.
My name's Lee Ellis.
My name is Matthew Yeager.
And my name is Mira Patel, and we're part of Group 4 in Lab Section 13.
We'll start with the goal and design requirements. The project goals were to create a standalone measurement system using the Arduino platform, and then create each measurement system using temperature, distance, and depth. Assess the resolution of each system and create ways to improve the resolution. And finally, debug the code and test measurement systems to ensure that they operate properly.
The requirements for the temperature measurement system, we have to ensure the system would measure a range of 0 to 100 degrees Celsius, have a resolution of at least 0.5 degrees Celsius, and have the LCD display output the temperature measurement. For the distant measurement system, the measurements were made using the ultrasonic sensor. The range was to be between 5 and 50 centimeters, and the display for the distance would be using a dial using a servo motor. And then for the water depth measurement, the range of this system would be between 5 and 50 millimeters, and the display would also be by dial using a servo motor.
So now we can move on to the strategy that we had. So for our strategy, we knew we had to complete our lessons for the necessary components in order to get an understanding of how they worked. That included lessons 11, 13, 14, and 21. Then we went and created the systems in order to check to make sure that they were working properly. After that, we continued to debug the test systems in order to remove software-related issues. Then we collaborated and improved the code in order to improve the resolution of the system. And then finally, we collaborated with each system with known test samples in order to create trend lines and confidence intervals and the R-squared value.
Next is our design steps that we took for this project. For the temperature design, we completed the lesson for the thermistor and the LCD display. After completing that, we wired the Arduino with the thermistor, a resistor, and an LCD display, as shown on the right of the slide. One problem that occurred was that the LCD did not display anything, it was just lit up. And the way that was fixed was adjusting the potentiometer on the back of the LCD with a screwdriver.
Distance design steps. To complete the lesson for the ultrasonic sensor and the servo motor, wire the Arduino with the ultrasonic sensor and the servo motor. Then check the code and debug if there's any issues with the coding.
Next, the depth design steps were taken. We complete the lesson for the water sensor and the servo motor, and then wired the Arduino with the water sensor and the servo to complete the circuit. One issue we had here was the sensor was outputting values that were random, and this was fixed by changing variable types of float instead to int.
Now we have our calibration steps. So for the temperature measurement system calibration, we placed the thermistor in contact with the test surface and then recorded the reading from the LCD display. Then we obtained 5 different temperature measurements with the values from the LCD. Using regression analysis, we calculated the required data for both data sets.
For the distance measurement system calibration, we placed a block in front of the device, recorded the distance from the ultrasonic sensor to the block using a ruler, and then we marked that distance with marked the distance the dial moved with what we recorded off of the ruler. We did this for the range that was required. Next, obtain 3 distance measurements, recording the dial readout and actual measurement using a ruler, and then complete the previous step for 10 data points. And after that, for both the 3 data points and 10 data points, use regression analysis to calculate the required data for both data sets.
water depth measurements and system calibration. First, place the water sensor in a container with water. Record the distance from the bottom of the container to the water's surface with a ruler, and mark the digital position with the distance measured. Do this for the required range. Next, obtain 3 depth measurements, recording the dial readout and actual depth with a ruler. Then complete the previous step for 10 more data points, excuse me. Finally, using regression analysis, calculate the required data for both data sets.
Next, we did significance. For the temperature measurement system, the significance was coding and debugging the sensor itself. We also had to use the thermistor and resistor to reliably measure the temperature. And this knowledge of temperature measurement system could be used in the future to help systems where temperature measurement is necessary to ensure safe operation of machines, like an engine, for example.
So then with our distance measurement system, the main principles we learned were how to calibrate distance measurement systems and how to code an ultrasonic sensor to output distances. One scenario in engineering could be making a measurement system to check the alignment of 2 parts. For example, if 2 plates are parallel with one another.
And then finally, there's the depth measurement system. The depth sensor is a useful way to measure depth, but is not as reliable as other methods. And one test that would be useful is where a depth sensor could measure the amount of fluid in a cylindrical tank by measuring the height of the water in the tank.